Welcome to chemistry, to Unit 2, where we finally get to delve into what we typically think of as chemistry, the world of the elements that make up everything around us. So you're probably familiar with at least some of these elements, you've seen their names, you've heard them, and so we're going to learn a little bit about what they're made of and how they're put together to make everything around us. So we've come a long way. The early Greek philosophers, Aristotle thought that there were 4 elements: fire, air, earth, and water. Democritus thought that everything was made up of these tiny indivisible things he called atomos, meaning indivisible in Greek. Since then, our understanding of elements, of the atoms, of the world around us has transformed dramatically. And we have identified 90 naturally occurring elements and created 28 others. So our modern periodic table has 118 elements. Alone or in combination, these elements make up our bodies, our world, our sun, our entire universe. So we're going to explore these elements in depth. So the most abundant element in the Earth's crust is oxygen. Almost 50% of the Earth's crust is made up of oxygen. And that might have surprised you because we think of carbon as the foundation of life, and it's actually a very small portion of what's in the Earth's crust. And if I had to ask you to guess, what do you think the most abundant element in the human body is? Might surprise you again, it's oxygen. Now, you guys probably have heard the statistic that we are 70% water. And if you think about water, it's 2 hydrogens and 1 oxygen, but oxygen is a lot more massive than hydrogen. And so that's why we're mostly made of oxygen, because we're mostly made of water. There are a lot of other trace elements in the human body. You might be surprised to learn that carbon is less than 20% of it. Okay, chemical symbols. These are the things we typically think of when we think of chemistry. Every element has its own unique symbol. It may be a single capital letter, or it may be a capital letter and a lowercase letter. We used to have some that had 2, but now we only have 1 lowercase letter. Usually, these correspond with our name for them. So C for carbon. Sometimes they might seem a little bit odd, like Cu for copper. In that case, it's usually based on a Latin name, although we do have a few that come from other languages as well. It is really important when you write your atomic symbols that you are very clear about an uppercase letter at the beginning and a lowercase letter for the second letter. It's not okay to write them both as capital letters, and it's not okay to write both of them as lowercase letters. So here are some of the common elements and symbols. You are not going to have to memorize the elements and their symbols in this class. You will always have a periodic table, but it's a good idea to become really familiar with your periodic table so that you can find things quickly. And we're going to talk about the patterns of the periodic table, and that might help you to become more familiar. So just a few of them. We have nitrogen, you're probably really familiar with. Sodium, I think you're probably also familiar with as Na. So that's one of the ones that does not correspond with its English name. Gold is Au, silver is Ag. So there are some that are aligned with their English names and some that are not. Okay, so we talked in the last unit about elements, compounds, and mixtures. It's important that we recognize that an element is the smallest unit that can retain its chemical properties. And when 2 elements combine to make a compound, they both lose their own chemical properties and gain new chemical properties. For example, chlorine is an element. Sodium is also an element. Sodium is an explosive metal. Chlorine is a poisonous gas, and yet when we put them together, we get sodium chloride, which is table salt. Very, very different from either of the elements that make it up. Another example, we can take hydrogen, that's an element. Oxygen is an element. Hydrogen is an explosive gas. Oxygen is fuel for fires, but when you put them together and bond them, we get water, which puts out fires. So again, very, very different from the individual elements that make up the compound. Now, when we combine salt and water, we get salt water. There is no chemical reaction. It's just a mixture. So the compounds of that mixture retain their individual properties. And just a review from last unit, we remember that mixtures can be separated by physical means. Compounds are pure substances that can only be separated by chemical means. And elements are a specific subcategory of pure substances. And if we separate those subatomic particles of the element, it no longer retains the properties of that element. So when we put our elements together to make compounds, we write chemical formulas. And these chemical formulas describe the types and numbers of each element that are present in the compound. They're going to use an elemental symbol followed by a subscript representing the number of the element in that compound. And they're generally written with the element that is furthest left on the periodic table first. So just a few examples. So CO2, we're going to learn the naming conventions. We're going to call this carbon dioxide, but we can look at its chemical formula and we can see that it contains 1 atom of carbon and 2 atoms of oxygen. And then we have dinitrogen pentoxide, contains 2 atoms of nitrogen and 5 atoms of oxygen. And finally, we have tetraphosphorus decoxide. It contains 4 atoms of phosphorus and 10 atoms of oxygen. So if you have any questions, as always, make a note and I will be happy to answer them at the beginning of class.